Okay, so I want to start working on indexed rendering. Here's the basic idea. Let's say, well, the classic idea is if we have a rectangle that we want to draw, in traditional rendering we just draw the three vertices, 0, 1, 2, but then how do we draw the other triangle? Well, we would make copies of those same vertices at the same positions and with exactly the same attributes. So we then have, I don't know, 3, 4, 5. So as you can see, some of these vertices get doubled up on, which is pretty pointless. So what we can do instead is we'll have a set of vertices which contain a whole bunch of data, and then we'll have a set of indices which refer to those. So I'll call this point index number 0, and that refers to the first position of the vertex buffer. And then we'll have index number 1 and index number 2, and those will be referring to these things in the vertex buffer. And then I'll have index number 3. Then I need to state which order I'm going to draw these, fetch these points, and I'll do it like this. I'll go 0, 1, 2, and then 2, 3, 0. Doesn't seem like a massive saving, but in the long term, as we add more and more vertices for larger models, we save on space. Now, that reconstruction does get done on the GPU, but it is more efficient than grabbing a whole chunk of wasted data. And there is another benefit to that, and that is later on when we look at ray tracing acceleration structures really like index drawing. So this is all well and good. What I would do is if I went to draw this, I would say something like, okay, so we'll say start index is equal to 0, index count is equal to 6. That's how we would draw that. But then things get a little more complicated, because what I want to do is not just have a whole bunch of different index buffers, but have a big lump where I grab everything all together. So let me go to a more complicated example. Let's say that we have a rectangle and a triangle, and each of them have their own index and vertex lists locally. So I'll call this index 0, 1, 2, 3. Really doesn't matter which order I draw this. And here we have locally index 0, 1, 2. Okay, so I'll consume the rectangle first. So I'll say, okay, the start index is 0. Index count is 4, because there are 4 things. Well, see, this is where things get a little more complicated, because let me draw this up. So I consume this data, and my indices will be going 0, 1, 2, 0, 1, 2, and then 2, 3, 0. So although we do get 4 indices when we go to draw this, we've really got 6. And I messed that up because that's the data that we would have available to us when we go to consume this. Okay, but let's look at the next triangle. So what I'm going to do is I'm going to take all these positions and these indices and append them onto the list that I've got right now. So what I would do is I would look and I would say, okay, how many indices have already been defined? Well, it's easy enough to calculate that we have had 4 indices defined. So if we go, vertices I mean, we go look at vertices, we'll have some data for vertex 0, 1, 2, and 3. So we have 4 vertices so far, and we can check the size, the number of those, and I'll just do like a little local relabel. So I'll say, okay, now this is index 4, this is index 5, and this is index 6. But then, what is the start index? It's tempting to say that the start index is 4, because that's the first thing that I've got here. But if I look at my indices, because this is what I use to draw, when I say draw starting at index 0, drawing 6 things, it's starting from position 0, reading the first 6 things within my index buffer. Okay, so start index. Well, if we go 0, 1, 2, 3, 4, we're going to start actually drawing some of the data which was defined in the rectangle before, which is really not good and really confusing and hard to debug. So what we do instead is we take the number of indices which have been defined so far, and that's the start index for the next shape. So again, I'll pop this data on. So we have 4, 5, and 6. And then index count, it's clear to see from the local index data, which has been defined, that we have 3 indices. This is a very simple shape. The number of indices is the same as the number of shapes. So again, if I were to draw this, I would start at position 6 within my index buffer. So I go 0, 1, 2, 3, 4, 5, 6. So I'm completely free of the previous shape. And then I take the next 3 indices. And of course, well, now the first one is going thing 4. So 0, 1, 2, 3, 4. That's the new triangle position. And that's sort of how we do it. So this has been an overview of what what indexed rendering is, and how we might want to take a number of shapes and compress them together into larger lumps of data. Okay. So this has actually been so useful. I'm actually going to clip this and I'll put this in my fundamentals playlist, but I've also got a Vulkan thing to do, so I'll see you in one of those.